So doing what we've been doing, we're going to find a point estimate and a confidence interval, this time for population variance or population standard deviation by taking the square root. But we have formulas for variance. So the point estimate is the sample variance, which is S squared. So the sample standard deviation would be the point estimate for the population standard deviation. So what I have written down here is that if you can find out a way on your calculator to do this chi-square distribution, please let me know. The tests that we have that involve this chi-squared isn't really what we're trying to do. So if you can figure it out, let me know. Extra credit. But we're going to have to use these formulas for variance. So the lower bound and the upper bound. So n, which we can find, s squared, which we can find, and then that chi-squared alpha over 2 is kind of like z alpha over 2 or t alpha over 2, but we're going to use our chi-squared chart to find a critical value. We're going to use that, and then chi-squared 1 minus alpha over 2 is the same idea. So we're using the chi-squared distributions here. So example 2, table 4 shows the sale prices of 12 randomly selected 3-year-old Chevy Corvettes, constructed 90% confidence interval for the population variance and standard deviation of the price of a 3-year-old Chevy Corvette. So we're going to start by finding our point estimates, which are S and then S squared. So S for standard deviation, S squared for variance. So add these values to list 1. So when I go to stat, edit, I input these values for list 1. I'll just make sure that I actually typed them in right because I've messed that up a couple times. And then I am going to calculate one variable stats, and it's going to tell me S. So S is equal to 2615.19. And we are using S, or I guess technically they say that you do one extra decimal from what your data is, so I don't know, 19 for money or 0.2. It really doesn't matter. So S squared is whatever that value is squared. So 2615.19 squared is going to be quite a big number. So 2615.19 squared is 6839218.74. So what is that? Million, 6 million. It's a pretty big variance. All right. So then in order to do these formulas, I need to know n. And ultimately, it's because I need to know the degrees of freedom. I need to know that to use the chi-squared chart. So n is just the number of data values. So 3, 6, 9, 12. So n is 12. And recall that degrees of freedom is just 1 less than n. So there are 11 degrees of freedom. And then I need to, in order to get my denominators, I need to know alpha taken from the 1 minus alpha times 100% confidence interval. So if it's a 90% confidence interval, 90 is 1 minus what times 100%. So alpha is 0.1. Therefore, alpha over 2 is 0.05. If you take 0.1 divided by 2, you get 0.05. So I'm going to use the chi-squared distribution chart because our degree of freedom are 11. I'm going to find where the area to the right is 0.05 with 11 degrees of freedom. So that would be, let's see here. The area to the right is 0.05 with 11 degrees of freedom is 19.675. So that is this denominator right here. And then 1 minus alpha over 2, well, 1 minus 0.05 is 0.95. Use the chi-square distribution to find chi-squared of 1 minus alpha over 2. So chi-squared of 0.95, the area to the right is 0.95, with 11 degrees of freedom is 4.575. So I found all my pieces separately, so then that way when it comes to using this formula, I'm just plugging everything in. So n minus 1, well, n is 12, n minus 1 is 11. times S squared. So you can certainly write out my 6 million number. I'm just going to write 2615.19 squared over my chi squared of alpha over 2. So chi squared of alpha over 2 is 19.6775. So the lower bound for variance is, let's see, I'm going to do 2615.19 squared, which is my big long number there, times 11 divided by 19.675. And so the lower bound for variance is this 3823705.52. That's the lower bound for variance. So I'm going to put sigma squared. And then the upper bound for variance is the numerator is the same. So n minus 1 is 11. This is upper bound. S squared is 2615.19 squared. But then I'm dividing by my chi squared of 1 minus alpha over 2, which is 4.575. So the upper bound for variance is, let's see, when I take 2615.19 squared times 11 divided by 4.575, I get this big number, 16444,023.19. So the lower and upper bound for variance are those two numbers. The lower and upper bound for standard deviation is just taking the square root of each of those numbers. So when I take the square root of 382370.52, I get 0.43. And then for the upper bound, I get the square root of 16,444,023.19 is 4055.12. So I am 90% confident that the variance is between these two numbers, and then I am 90% sure that the standard deviation is between these two numbers.